Apply the sum and difference rules to combined derivatives. Well, before we can apply the sum and difference rules, it would probably be a good idea if we knew what they were. So we're going to let f of x and g of x be differentiable functions at x. And we're going to first look at the sum of two functions, so d dx of f of x plus g of x. And what this rule says is that if we want to find the derivative of a sum, all we have to do is find the derivative of each individual function and add them together. So d dx of f of x plus g of x is equal to d dx of f of x plus d dx of g of x. And similarly with subtraction, if we want to find the derivative of the quotient, or want to find the derivative of the difference, all we have to do is take the derivative of each individual piece and subtract. So now these two rules are super easy and super helpful, but don't get used to it, because as soon as we move on to products and quotients, not so easy. But it's easy here, so let's enjoy it. Our first example tells us to let h of x equal f of x plus g of x. It then tells us if f prime of 5 is going to be 9 and g prime of 5 is going to be negative 3. What is h prime of 5? All right, well, let's start off with our function. We know that h of x is going to be equal to f of x plus g of x. And now we're going to want to take the derivative of this. So we're going to end up with h prime of x is equal to, and based on our sum rule for derivatives, we know that if we want to take the derivative of a sum, we can just go ahead and take the derivative of each function individually. Meaning we're going to get f prime of x plus g prime of x. So great, we found the derivative. However, we're now looking for the general derivative. We're trying to find the derivative at x equals 5. So we can come in and we can substitute in 5. So h prime of 5 is going to be equal to f prime of 5 plus g prime of 5. Now, fortunately, in our example, we're told that f prime of 5 is 9. So we can make that replacement. We're also told that g prime of 5 is going to be negative 3. So we can make that replacement. And that's going to leave us with h prime of 5 is 9 plus negative 3. And 9 plus negative 3 is going to be 6. So therefore, h prime of 5 is 6. All right, let's take a look at another example, but this time we're trying to find the difference between two functions. So we're going to let h of x equal f of x minus g of x. And we're told that if f prime of negative 2 is negative 8 and g prime of negative 2 is 1, what is h prime of negative 2? So we're going to go about this the same way. We're going to start with our function. H of x is equal to f of x minus g of x. And I talk faster than I can write. All right, then we'll come in and we'll take the derivative. And as our derivative rule for the difference of two functions, we know we can just take the derivative of each piece individually, leaving us with f prime of x minus g prime of x, which is great if we were being asked to find the general derivative, but we're not asked to find the general derivative of the function. We're being asked to find the derivative at the specific point x equals 2. So now we can come and substitute that value in. So h prime of negative 2 is going to be f prime of negative 2 minus g prime of negative 2. And fortunately, our problem tells us that f prime of negative 2 is negative 8, and g prime of negative 2 is 1, which means now we're just going to subtract them, and negative 8 minus 1 is going to give us negative 9 as the derivative of h of x at negative 2. All right, this one looks similar but is a little bit different, because here we're going to let h of x equal f of x plus g of x, but now instead of being told what the derivative is, we're just given a function for f of x, which is 4x cubed, and a function for g of x, which is 7x. And we're being asked to find what is h prime of 4. All right, so our starting point will be the same. H of x is equal to f of x plus g of x. But since we're given actual functions now, we're going to want to substitute those functions in. So we know f of x is 4x cubed, plus we know that g of x is 7x. So when we want to take the derivative to find h prime of x, all we're going to do is we're going to take the derivative of each individual term. So the derivative of 4x cubed, we're going to use the power rule, and we're going to end up with 12x squared, plus the derivative of 7x is just going to be 7. Great! But again, we're not looking for the derivative of the general function, we're looking for the derivative at x equals 4. So let's plug it in. X prime of 4 is going to be, let's see, 12 times 4 squared plus 7. And then we can continue to simplify this. Let's see, so 4 squared is 16. 16 times 12 is going to be 192 plus 7, which will give us a final derivative of 199. Now that number 199 pains me a little bit because it's so close to 200 and we can't do anything to round it up, but that's neither here nor there. Next problem. Alright, so this next one's asking us to find the derivative with respect to variable w of 2w cubed plus 9w squared minus 6w plus 2. So again, we're trying to find the derivative of the sum of 4 terms. Well, based on our sum rule, we can go ahead and we can take the derivative of each individual term. Oops, that should be a minus. Minus the derivative of 6w plus the derivative of 4. Now we're just letting the writing catch up. There we go. All right, so we can go ahead and take the derivative of each individual term. Derivative of 2w squared is going to be 4. Oh, that's not a square. That should be, well, it is a square, but I should have wrote a cubed. So let's come in here and make that look a little bit neater. I'm just making it look less neat altogether. Alright, so 2w cubed is going to be 6w squared plus, let's see, 9w squared, the derivative of that is going to be 18w minus, the derivative of 6w is 6, plus the derivative of 4, since it's a constant, is 0, which will leave us with the final derivative of 6w squared plus 18w minus 6, and we can leave it like that, because we're not solving quadratic expressions, we're just finding derivatives. And last but not least, we want to find the derivative of f of x is equal to 5 times the cube root of x minus 6x to the negative 4th plus 4. So lots of fun stuff in here from previous videos. Alright, so again, we know that we can take the derivative of each individual term here because it is the sum. And let me just get rid of these weird black boxes I accidentally created. Alright, let's try this again. F prime of x. What's going on? F prime of x is going to be, and how do we take the derivative of radicals? So, maybe we can't just start off by taking the derivative. Looks like we're going to have to rewrite our function first. So, we're going to get 5, and let's see, the cube root of x to the first power. We can see here that the power is 1, and the root is 3. So we can convert that to have a rational exponent to be x to the 1/3 minus 6x to the negative 4th plus 4. And now we can go on to take the derivative. So f prime of x is going to be derivative of 5x to the 1/3 will be 5/3 x to the negative 2/3. Negative 6 times negative 4 is positive 24 x to the negative 5th. And then the derivative of 4 is 0, so we don't need to write it. So therefore, the derivative of 5 times the cube root of x minus 6x to the negative 4th plus 4 is 5/3 x to the 2/3 plus 24x to the negative 5th. Alright folks, and that is it for applying the sum and difference rules to combined derivatives.